So sixth period, I'm continuing where we left off. Fourth period, we already did this, but I know it got a bit rushed. So let me continue the lesson. First step, rewrite this in exponential form. Now I could have gone 81 to the 1/4 cubed. It doesn't matter the order. But now that I'm going to write it in exponential form and simplify it that way, I look at the 81. 81 reminds me of 3 to the 4th power. So I'm going to write it as 3 to the 4th to the 1/4 cubed. I just switched the spots here. Now that's gone. 3 cubed means 3 times 3 times 3, 27, plus or minus. Okay, number 4. Number 4, write it in exponential form. 10 to the 9th to the 1/3. Okay, it doesn't matter which one comes first. Now that I did that, I can simplify it. 10 cubed. The rule for the tens is that you just have a 1, and to the 3rd power means you will have 3 zeros. So if it was 10 to the 7th, it would be a 1 with 1, 2, 3, 4, 5, 6, 7. 10 million. Okay? And it's not an even root, so it's just 1,000. The next page. Now I have it in exponential form. I want you to change it to rad form and then simplify it. So I could rewrite this when it's a fraction. I take the bottom number, that is my root, and then 8 squared. Okay? There's a couple different ways to approach this. One way to approach this is going rad 64 cube root, and then try to find what the cube root of 64 is. What times 4? 4 cubed. Boom, there's my 4. Another way to go is to keep it as 8 is the same thing as 2 cubed. So 2 cubed squared, cubed root. Then boom, boom, that's gone. And then 2 squared is 4. I don't care how you get there, okay? But since it's the cube root, there's no plus or minus. Okay, so let me tell you again what I did for this one. This 8 turned into 2 cubed, so I could get rid of that cube root. Let's try the next one. Write it in rad form. Cube root, negative 125, parentheses, squared. This is this. I could figure out what negative 125 squared is, but I mean, that's ridiculous compared to the 64. The 64 was more reasonable to then go back. So I need to think of negative 125. So as I said, since squaring this is ridiculous because we can't use a calculator, I need to focus here. So I need to think, what to the 3rd power gives me negative 125? That's negative 5 cubed squared. Okay, I can keep that. I can put it in exponential form. I can keep it in rad form. I prefer exponential form. I don't care how you approach it at this point. You might get too crazy with all those parentheses, so you might want to do it in rad form. But either way, that's gone. Then it's parentheses negative 5 squared is 25. Okay, don't forget the parentheses. Number 3. Number 3 is a lot less going on. Maybe I should have made that number 1. Cube root of 64. That's written in rad form. I could now write it in exponential form and simplify it. I could write it in rad form and simplify it. Whatever I want, but the answer is 4. Let's go to the next one. 4 to the 5 halves, which is the square root of 4 to the 5th power. Now, 4 to the 5th, honestly, I don't know what that is. That seems unreasonable to me. That's a big number. I think it's like 1,024, but I totally could be wrong. So, but I see the 4, and it reminds me of 2 squared. So I could keep it in rad form, cross it off. I could put it in exponential form, which I prefer, of course. That's this squared right there. So this 4 is really the same thing as 2 squared. And then now top and bottom gone. 2 to the 5th. 2 times 2 times 2 times 2. I think that was 5. Whatever. It's 32 plus or minus. Okay? All right. That's everything. Now what I want to do is do some basic review. Right? If I have a problem that says, let's do the 3rd root of x to the 7th. Let's make it a really big one here. Let's do the cube root. Let's make it a hard one. Cube root of x to the 7th over So I'm going to simplify that. If I simplify that, actually, let's make it x to the 6th first, and then we'll step it up, okay? That's really x to the 6th over the cubed root of x to the 5th. So this I can put in exponential form, which seems easiest to me. Boom, that's x squared. I could also do piles of 3, x cubed and x cubed. I have 1 pile and 2 piles. That's my x squared. I could do it pile method 1, 2, 3, 4, 5, 6. I'm looking for piles of 3. Piles of 3. There's 2 piles of 3. I could do it in rad form. 2. Okay? I don't care. Get x squared. Now the problem is that I only have a pile of 1, but I need a pile of 3. So I need to give 2 more. But if I give it on bottom, I've got to give it on top. And now when I get my pile of 3, boom, the 5 is on bottom. And then x squared cube root of 25, I'm done. But what happens if this time, this problem doesn't say x to the 6th, it says x to the 7th. And this time, let's make it a 9. Okay, so this time I'm going to make it x to the 7th over 9. So it's not as easy for me to do this problem. That's when I might want to do my piles. So this is when I might want to go 1, 2, 3, 4, 5, 6, 7. And I'm circling piles of 3. 1 pile, 2 piles. So I have 2 piles, and I have 1 left over. I might want to write it as x to the 6th, x to the 1st. And there's my 2, and then I still have my radical there. Okay? There's so many different ways to do it, whatever you want. Over the 3rd root of 9. Now, some of you see this and go, it looks like a pile of 1. But technically, that 9 is really a pile of 2. So that 9 is really 3 times 3. So I already have a pile of 2, so I need to give 1 more to get my 3rd pile. Now I have a pile of 3. Boom, there's my 3. Now these are both a radical, so it's going to be x squared cube root of 3x, and since it's an odd root, it's not plus or minus. I'm done. Okay? Hopefully that acknowledges some of the issues that you might have had, if you had any. So let me acknowledge what the homework is too. So it says it on your packet, but just in case you aren't sure, number 2. Okay? And you don't need to see any of the answers because it's just changing it from one form to the next.